Hi guys, I'm going to start by going over question number 3 that you should have skipped on the homework, and this way we can discuss it. Well, you can hear me discuss it, I guess. Okay, so first it says water is flowing from tank 1. So if water is coming out, the slope is going to be negative because the rate of change would be a constant because it's flowing out at the rate they're telling you. However, it's going to be negative because it's coming out. And then the water is coming from tank 1 into tank 2. So tank 2, the water level is going to rise. Therefore, that slope is going to be positive. So when I write the equations, I'm thinking about how much water there is originally, and then what is that rate of change doing. So for the first one, it's coming out at a rate of 6 gallons per minute. Therefore, the other tank fills up at a rate of 6 gallons per minute. So if you look at this, those are the equations I got because it started with 1,540. And the other tank started with 236. Okay. So it says, how long will it take to the nearest minute for the two tanks to have the same number? So when they say things like the same, they're talking about things being equal. So I took each expression and I set them equal to each other. And then I solved that. So I solved it by moving this 6x over to the other side and moving this 1,540 to the other side. And then I divided each side by 12, giving me 109. So the next question says, will it take longer or shorter than 2 hours? So this comes back to our Unit 1 conversions. And 109 minutes is less than 2 hours because 2 hours would be 120 minutes. So I want to say it will take less than 2 hours. Okay, so you're going to work on page 14 today, 14, and then I will go over the first 4 with you. So we're going to start with this question, and it's in the upper left corner. So my idea here is that I am going to set these equal to each other. And it's basically saying that if this is equal to y and that is equal to y, this is equal to that. Okay? So since they're both equal to y, they have to be equal to each other. So I set them both equal to each other, and then I solve. So I took each expression, the expression here, and the expression here, and I set them equal to each other. By setting them equal to each other, I'm creating a single equation with one variable. And that is the main idea of a system. So if you have two equations with two variables, your first job is going to be to combine them to make one equation with one variable. And then I just use my equation solving skills. So I did the addition property of equality, and I subtracted 0.5x from each side. Then I used the addition property of equality again, and I added 0.65 to both sides. And then I did the division property of equality, and I divided both sides by -3. And that gives me x. Don't stop with x because it's sort of like going on a date by yourself. All right, you're all alone, you need a partner. So you just take the answer you got for x and you substitute it back into either equation, and then you get your y. So it's sort of like for every x, there's a y, okay? All right, so you want to stop the video and try the next one, and then start the video again after you've done it. Okay, so example 2, I'm going to do substitution again. I'm going to take this expression and substitute it right over here. Okay, and for that, you're going to need to use the distributive property. Of course, this happens right in the middle, right? Okay, so One more time, another interruption. So right here, okay, I substituted that in. So this expression was substituted right there. So then this is the distributive property. And be careful with that. Negative times negative is positive. So I end up with this equation that says 10 equals 10. We had that before in Unit 2 with solving equations. When you get 10 equals 10, that's always true. Okay, so when you have something that's always true, that means that you're going to have infinite solutions. Okay, and something that is always true will give you infinite solutions. So that means any value of x and y will work. Any value of x or y will work. This is always true. Remember, that's called an identity equation. All right, so example 3. If you didn't already do this, then pause the video and do it. Okay, so this is going to follow the premise of the first one, where if something is equal to y and something else is equal to y, then they have to be equal to each other. So I'm going to take this expression and set it equal to this expression. And you might notice something right away, that you have the 1.5x and the 1.5x. So remember, same slope, parallel lines, same slope, parallel lines. So you get what's called a contradiction. And a contradiction is something that is never true. So that's why we're saying no solution. So there are no x's or y's. There's no points that will ever make this true. That's called no solution. Okay, and you might remember this from when we did graphing, when we had consistent, inconsistent. Okay, so you have 3 choices. Consistent is when you get a solution, and that's normally what happens. And then inconsistent is when you get no solution. That's the parallel lines. And then you have what's called dependent, and that's when you get infinite solutions. And that means everything on that line, all the x's and all the y's together work. Okay? All right, so example 4. Since this is solved for y, I'm going to take this expression and I'm going to substitute it right here. Okay? So again, stop the video, do this by yourself, and then we're going to go over it. All right. So as you see, I took this right here and I put it right here. Then I use the distributive property. And you have to be careful with that. Make sure you get both. Okay. And then I decided to move the subtracting 1x by adding 1x. That's the addition property of equality. And then moving the subtracting of 25. Again, addition property of equality. And then dividing by 3.5. So when you divide by 3.5, you get x equals 20. And you have the 20. And for every x, we want a y. So I substitute 20 back in, and that gives me the answer 5. All right. So that is page 14 in the packet. You are going to work independently on page 15. All right. Hope you have a great day and that everybody is safe. Take care.